Hello, Doc Sig here to talk about ions, what they are, how they're calculated, and periodic trends. First, let's go ahead and define an ion. It's an atom or group of atoms that has a net positive or net negative charge. Net meaning the remaining ionic charge after deduction of charges. Now we can have a cation, which is a net positive charge result, or an anion, which is a net negative charge. Okay, so here's some memory mechanism. I'm positive it's a cation, and there's some pretty cute shirts out there if you're so inclined to search. Onions sound like anions. Onions make you cry. Anions. In this video, we'll talk exclusively about monoatomic, mono meaning one atom. First, let's go ahead and work on the math, and then we'll see resulting trends that develop on the periodic table. Now, I'm going to be working with groups, some call them family, right? And that's how, but I'm going to use the term group when I'm going through the table. Remember that elements on the periodic table, though, they're all neutral and no charge. So let's look at lithium, which is in our group 1A, or the alkali metal group. So lithium, we're going to have one valence electron. The atomic number is 3, and that means 3 protons. And because it's neutral, it has 3 electrons. But lithium, having that one valence electron, it's going to lose it. When it loses that one valence, it goes back to noble gas configuration, which means more stability. This group is super reactive for that reason, wants to get rid of that one valence electron real fast. And so when it loses it, we have 3 protons, because we're not changing that. That's not the definition of an ion, but we're going to lose an electron. So we're going to wind up with a +1 charge. Hey, a cation right there. When we write this, though, we're going to use superscript, so it'd be Li+. In chemistry, we don't put the 1, so that's just implied. All right, so now we're going to move right next door, group 2A, or the alkaline earth metals. These guys have 2 valence electrons, and so they want to give up those 2 valence electrons to go back to noble gas stability. So let's look at calcium. All right, here's your 2 valence electrons, or Lewis dot structure. We'll get that in a different video. It has an atomic number of 20. That means 20 protons. Because it's neutral on the periodic table, 20 electrons. But if I lose 2 electrons, I now have 20 protons plus 18 electrons, and that gives me a +2 charge. So when I write this, I'm going to go Ca 2+ superscript on the 2+, or Ca +2. Doesn't matter which one you use, okay? Just make sure superscript. We're going to skip over that transitional metals. They don't follow this rule. We'll talk about some in there to memorize later on. But right now, let's go to the halogens, group 17 or 7A. And if you're wondering why I didn't look at the noble gases, guys, they're not going to follow this rule. They have octet. They've achieved that stability. They are neutral, or inert is the word to use with them. But the halogens, right? We have 7 valence electrons. Here's Lewis dot for fluorine. So fluorine has an atomic number 17. That's 17 protons. 17 electrons. Okay, that gives you that 0 neutral charge on the periodic table. But if I gain an electron, now I'm going to have 17 protons plus 18 electrons to get a -1 charge. Hey, that's our first anion, right? So we'd write F-. Okay, no 1 again. We don't do that in chemistry. Let's move to the left one. So group 16, 6A, 6 valence electrons. Now these guys need to gain 2 electrons to get to that octet 8 valence electron noble gas configuration. So here's oxygen. Here's a Lewis dot. Oxygen has 8 protons, 8 electrons on the periodic table. We're going to gain 2 electrons. So we're going to have 8 protons, 10 electrons. That gives us a -2. All right, that's an anion again. Okay, so I'd write this as O2- or -2. Again, superscripts. Last group I'm going to follow with this trend is group 15, 5A. 5 valence electrons, meaning these elements need to gain 3 electrons to get to a valence of 8, octet rule, noble gas configuration. So nitrogen, 7 protons, 7 electrons, that's the neutral charge. Now when I gain 3 electrons, I'm going to have 7 protons plus 10 electrons to get a -3. We'll denote this as n to the -3 or n3-. And that's an anion again. All right, so besides the trends I talked about, there's a few just to memorize. So we'll have silver, zinc, aluminum, and cadmium. All cations, and their charges are written there. Okay, those are ones to memorize. The other ones in the transitional region, they're going to change, have multiple charges. The metalloids, we don't do that. We don't consider those in these trends either. Multiple charges. And if you didn't pick it up, all cations are metals. All anions are nonmetals. And this is going to come into play when we start naming. Let's look at how this plays out on the periodic table. So group 1A plus 1, group 2A plus 2. Skip over the trans. Trans means across periodic table. Skip them. Let's go all the way to our halogens, right? Group 17, 7A, minus 1. Group 16, 6A, minus 2. Group 15, 5A, minus 3. And then we got the few to note, okay? Our silver, zinc, aluminum, and cadmium. All right, until next video, see you later.